In this video, we're going to introduce systems of equations. When you have a systems of equations, it's basically taking two equations, graphing them on the exact same graph, and finding out what happens. So we're going to start with these two lines right here. We're going to graph these two lines on the exact same graph, and we're going to see what happens. I'm going to start with this red one. Now, first thing you need to do is look and see what form it is. The form is going to determine how you're going to graph this. This is y is equal to 2x minus 3. That's in slope-intercept form. That means I'm going to use the y-intercept and then the slope to graph this. The y-intercept is where I put my first point. So my first point is going to be on negative 3. So on the y-axis, I go down negative 3, 1, 2, 3, put my first point. Then I use the slope. Slope is usually a fraction. How do I write 2 as a fraction? That's going to be 2 over 1. That means I'm going to go up 2 over 1 since it's positive. So I'm going to go up 2, 1, 2 over 1. Up 2, 1, 2 over 1. I can continue to use that slope to generate more and more points on this line. I'm going to use my ruler and draw my red line. Now I'm going to graph this line right here in black. That's the one I'm going to graph next. It's also in slope-intercept form. That means I graph the y-intercept first and then use the slope to find other points on that line. So let's put our first point at the y-intercept, which is positive 2. So positive 2 right there. Then I'm going to use the slope. The slope is negative 1/2. That's telling me to go down 1 over 2. So that's what I'm going to start doing. I'm going to go down 1 over 2 from this point. Down 1 over 2. Down 1 over 2. Down 1 over 2. Give me a few points on that line. Then I'm going to draw the black line. Now when I draw both of these lines on the exact same graph, look what happens. The red line and the black line intersect at one point. In fact, I can write down the coordinates for that point. The coordinates for that point, 1, 2. The x-coordinate is 2. Remember to use parentheses. The x-coordinate is 2. And the y-coordinate is 1. Now what does this mean? This is the only point. Notice I've got a bunch of other points on the red line and a bunch of other points on the black line. This right here, 2, 1, is the only point they have in common. So let's try another one. Let's graph both of these lines on the exact same graph and let's see what happens. I'm going to start with the red one first. First I'll look and see what form it's in. Looks like it's in slope-intercept form. That means I'm going to use the y-intercept first and then use the slope. The y-intercept is positive 3. So on the graph, I'm going to go up 1, 2, 3, put my first point. Then I'm going to use the slope to generate points on this line. The slope is telling me to go down 1 over 2. So from this point right here, I'm going to go down 1 over 2. Down 1 over 2. I can continue to do this to generate a lot of points on this line. I'm going to draw my red line. Now I'm going to graph the black line. The black line is also in slope-intercept form. That means I need to graph the y-intercept first and then use the slope. The y-intercept is negative 4. That's where I put my first point. So 1, 2, 3, 4. That's negative 4 on my graph. My slope for the black line is 3. Remember, most of the time to use the slope, it needs to be written as a fraction. How do I write 3 as a fraction? That's 3 over 1. That means I need to go up 3 over 1. And that's what I'm going to do from this point right here. I'm going to go up 3, 1, 2, 3, over 1. I'm going to do it again. Up 3, 1, 2, 3, over 1. And look, those two lines intersect at that point right there. I'm going to write down the coordinates for this point. Looks like I go over 2, so the x-coordinate is 2. I go up 2, the y-coordinate is 2. This is a solution for both of these equations. For example, I could take these numbers and plug it in here and it's going to work. It's the only set of numbers that's going to work in this equation. So what I'm going to do is I'm going to take those numbers and I'm going to plug it into the black equation and see what I get. Y is equal to 3x minus 4. That means I want to plug my 2 into the y, plug a 2 into the x, follow my order of operations. This should be equal to 2 once I do all the math. That is a solution for the black line, 2, 2. Now I'm going to do it for the red line. I'm going to plug those two numbers in the equation. Plug a 2 in right here. Negative 1/2 times 2 plus 3. Negative 1/2 times 2. 2 times negative 1 is negative 2. Negative 2 divided by 2 is negative 1 plus 3. 2 is equal to 2. These two numbers are the only two numbers that work for both of these. If I plugged in different numbers in here, like a 1 and a 5, it wouldn't work. A 3 and an 8 wouldn't work. A negative 2 and a 0 wouldn't work. These are the only two numbers that work. So when you graph these two lines on the exact same graph, a lot of times they're going to intersect. But do they always intersect? No, they don't always intersect. So let's look at a situation where I graph two lines on the exact same graph and they don't intersect. Our next example. I've got one line that's in slope-intercept form and I have one line that's in standard form. The red one is in slope-intercept form. I'm going to graph that one first. Since it's in slope-intercept form, the way you graph something in slope-intercept form, because it says y is equal to, I graph the y-intercept first. Y-intercept is way down at negative 9. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9. Way down here. Then I'm going to use the slope. What's the slope for this one? What number is in front of that x? There's a 1. And I also have to write it as a fraction. What's 1 written as a fraction? 1 over 1. So from this point right here, I'm going to go up 1 over 1. Up 1 over 1. Up 1 over 1. I could continue to do that to generate a bunch of points. Take my ruler, draw my red line. My red line goes with my red equation. Now I'm going to graph the black line. Well, what form is the black line in? It's in standard form. How do you graph something in standard form? You use the x and y intercepts. So I write it twice. To find the x-intercept, I don't need the y. Look like my x-intercept is negative 4. So this is my x-axis. I go back 4. 1, 2, 3, 4. There's my first point. I need to use the y-intercept as well. To find the y-intercept, I don't need the x. I need to solve this little equation right here by dividing both sides by negative 1, because that's the number in front of the y. Y is equal to, a negative divided by a negative is a positive. The y-intercept for this one is 4. 1, 2, 3, 4 on the y-axis. I graph this line, and let's look and see what happens with this one. Looking at this, these two lines intersect. And what do we call two lines that don't intersect? Two lines that don't intersect are parallel. But does this one have a solution? There is no solution to this one. The other one had a solution. This one right here has a solution. The solution is 2, 2. The solution for this one is 2, 1. The point that they intersect is the solution. Does this system of equations have a solution? No, it does not. The reason why, these two lines never intersect. There is no solution on this one. So we've got two situations so far. We've got, I'm going to graph two lines on a graph and they're going to intersect at one point. I could graph two lines on the exact same graph and they never intersect. That means they would be parallel. There would be no solution to that. And then we could have this situation. I've got two lines that I need to graph. I'm going to graph each one of them. One of them is in standard form, the other one is in slope-intercept form. The red one's in slope-intercept form. When you graph something in slope-intercept form, you need to graph the y-intercept first. So let's do that. The y-intercept for this one, -1. So I'll go down to -1. Then I use my slope. My slope tells me I need to go up 1 and over 2. Up 1 over 2. Up 1 over 2. Up 1 over 2. I could continue to generate points. I'm going to use those, and I'm going to draw that red line. So the red line looks like that right there. Now I'm going to graph the black line, and I'm going to see whether or not they intersect or whether or not they're parallel. The black line is in standard form. To graph something in standard form, I need the x and y intercept. So what I'm going to do is I'm going to write it twice. To find the x-intercept, I don't need the y. Look at that, the x-intercept is 2. So let's do that. The x-intercept is 2. This is the x-axis. So I'm going to put an x-intercept of 2 right there. I need to find the y-intercept. To find the y-intercept, I don't need the x. I solve this simple equation right here, and I find that the y-intercept is -1. So the y-intercept is -1. Now I'm going to draw a line connecting those two black dots right there. And when I do that, this is what I find. I find that the red line and the black line are the exact same line. Where do these two lines intersect? They intersect at every possible point. That means which ones are solutions? Every point on the red line is a solution to the black line. Every point on the black line is in common with every point on the red line. So what would I write down as an answer for this? Am I going to be able to write down every single one of those points as an answer? No, what you would write down is infinite solutions. So what we need to do next is we need to make a chart that's going to help us figure out the answers. What we need to write down is the answers when these three situations come up. The three situations are this. They could be the exact same line. They could be parallel. Or they can intersect at one single point. So that's what we're going to do next. We're going to make a chart that's going to help us answer those questions, or a chart so we'll know what to write down as the answers to these systems of equations. We're either going to write down the point where they intersect, we're going to write down the fact that there's no solution when they're parallel, or we're going to write down infinite solutions when they're the exact same line. So what we're going to do now is we're going to draw a little chart that's going to help us figure out what to do when we get to these three situations. And the three situations, again, are the lines could be parallel, the lines could intersect at one point, the lines could be the exact same line. And we need to make this little chart so we'll know what to write down when we get these three situations. This little chart is going to help us answer those questions or realize what we need to write down when we get to those situations. So the first situation could be this. The first situation could be these two lines do not intersect. So let's draw a picture of two lines that do not intersect. And what do we call two lines that do not intersect? Two lines that do not intersect are called parallel. So if we're doing this, we're working our systems of equations problems, and we get two lines that are parallel, the thing that we write down as the answer is no solution. So when we're doing these problems and the lines are parallel, they never intersect, there's no point in common. So the answer to this is no solution. Okay? The next situation is going to be like this, where they do intersect. So we've got a situation where these two lines intersect. What do we write down as the answer? That point, that one solution. This one solution right there where they intersect, that's going to be our answer. The coordinates could be 2, 3, 1, 1, 4, 5, -8, -10, whatever the coordinates are, that's what we write down as the answer when they intersect. And then the third situation. The third situation is where we graph one line, like this right here, the red one. And then we go and graph another line, and when we graph the other line, it ends up being the exact same line, like this right here. When we have this situation, what do we need to write down as our answer? We need to write down infinite solutions. So if there is one point, I write down one solution. If they're parallel, I write down no solution, because there's no solution to this problem. There's no point that parallel lines have in common. If they're the exact same line, there's an infinite number of solutions. They're also going to use other words to describe this. The other words that they use to describe this, for something that's parallel, something that has no solution, they're going to use the word inconsistent. This is an inconsistent system of equations. They're going to use this word to describe when you actually do have a solution. Consistent. This one's also consistent, but there's a difference between these two, so we're going to need another word to describe it. Not only are both of these consistent, we need another word to describe the fact that this one only has one solution and this one has infinite solutions. If there's only one solution, it's not only consistent, but it's also independent. This one then is going to be, and they're going to ask you to use these words to describe these three situations. Here are the three situations. The lines are parallel. There is no solution. There's no point that they have in common. That's going to be inconsistent systems of equation. We're going to graph them. We're going to find out that they intersect at one single point. That one point is our answer. That means they're consistent. This systems of equation is consistent and independent. If I graph two lines that end up being the same, the answer to that is there's an infinite number of solutions to that. That means that system of equations is consistent and dependent. So what you would do is you would use this chart right here to help you answer what kind of system this is. What type of system was this one right here? Which one does it match up with? It's the exact same line. If it's the exact same line, then it's going to be consistent and dependent. What if they're parallel? If they're parallel, it's going to be inconsistent. If you graph those two lines and they intersect at a single point, you've got one answer right there, and that would be the answer for this system of equations. What type of system of equations would it be? Consistent and independent.